Hey guys, Miss Pipel here. In today's video, we're going to be looking at covalent compounds and their nomenclature, meaning how to write the formulas and name covalent compounds. We're not going to be talking about Lewis structures. We'll wait on that for a couple weeks. And then one thing we need to realize is that covalent is similar for that. We can call these molecular compounds as well. So covalent is equivalent to molecular. So let's get started. So to summarize a covalent bond, remember these are between two non-metal atoms and they share a pair of electrons. An analogy we can use for this is that they're playing tug of war with the electrons, and I think this image here with the hydrogens with the cowboy hats on does a really good job of kind of demonstrating that and showing that they both are holding on to that rope, they're both pulling on those pair of electrons, and that is the analogy of the two nuclei of the atoms involved in the bond pulling on those pair of electrons. So when we name and write formulas for covalent compounds, we have to remember that we're dealing with two nonmetals, so that's going to be our identifier for if we're seeing a compound or a formula without any context. If it has two nonmetals in it, that means that we're dealing with a covalent compound. Okay? When we name and write formulas for covalent compounds, we are going to be dealing with these prefixes. These are prefixes that you are not going to be provided. You need to memorize these or just know them. Most of these are things that you have seen many times in life before. Okay, mono, like monopoly or a monarchy. Those mean one person or one company in charge. Di means two, tri means three, a triangle has three sides, a tricycle has three wheels. Tetra means four. Okay, Tetris, if you've ever played Tetris, each of the pieces in Tetris has four blocks in it, so check that out next time you do that. Tetra means four. Penta means five, pentagon. Hexa means six, hexagon. Hepta means seven. Octa means 8. So octagon, octopus, has 8 tentacles. So those are ways we can remember that. Nona means 9, and then deca means 10. Okay? The setup for how we write names, okay, we will write the prefix depending on how many of that element there are in the formula with the name of the first element. And then paired with that, we're going to put a prefix and the name of the second element ending in "ide." Remember, that's the cue that we are dealing with a compound here. That's what tells us that these two things are chemically connected to each other. It's like the married name, right? We now change the ending to "ide" to show that they're chemically connected. One note we do need to take into account is that we only use mono on the second element. Frequently, we'll have compounds that start with just a single atom of a particular element. We don't need to use mono in those instances, and so I'll show you that with the practice. So let's go through some examples, okay? These are pretty straightforward. So we have boron trifluoride as our first example. Okay, so boron, listed there, no prefix, so that's just going to be B. And then fluoride is the second part of this formula. And then our prefix of tri tells me that there are 3 fluorides. So BF3 is that formula. The next one here, dihydrogen monoxide. Okay, so our first element is hydrogen. The prefix in front of it is di. Di, according to our prefix table before, means 2. Second element is oxide or oxygen, and mono means 1. So H2O. So next time you go to a restaurant, if you want to order some water, order some dihydrogen monoxide. That's technically the proper chemical name for water. And the last one here, carbon tetrachloride. So carbon tetrachloride, first element is carbon, only one of those, no prefix listed. You can see that the mono is omitted there. And then chloride, let's try that again. Chloride is Cl, and I have 4 of those because this is tetra. And there you go. Going the other way, okay, hopefully just as straightforward. So we're going to write out the 2 elements, the second one ending in "ide," and then use the appropriate prefixes here. So this first one, N2O4. So the prefix for 2 is di. That element is nitrogen, so di-nitrogen. Second element here is oxygen, and I have 4 of those. So that's going to be tetroxide. Okay, we don't need to have the 2 vowels there, so you can just do tetroxide instead of tetraoxide. But I won't take off for either of those, but you do need to be able to recognize it without those 2 vowels there. So dinitrogen, 2 nitrogens, and 4 oxygens, tetroxide. The second one here, first element is carbon. I only have 1 carbon in this formula. I know that because there's no subscript on it, so just having the symbol means there's 1. And I remember back to the note that I gave you earlier that says you don't need the mono prefix on the first element, so we're just going to say carbon. The second element is, again, oxygen. Let me make some room here. So that's going to be 1 oxygen or carbon monoxide. Okay, notice that mono is included in the second element, but not the first element. So mono is important to include, but only when it's with the second element. So carbon monoxide there. Okay, and then the last one here is P with 5 chlorines. So P represents phosphorus. 1 phosphorus listed there, so we don't need a prefix because it's the first element. And then penta for 5, and then chlorine we change to chloride. So phosphorus pentachloride. Okay, so try your practice on this using prefixes and making sure to be detailed with those prefixes.